Welcome to mm, whatever channel I call. Okay, welcome to my channel. Today we are going to learn about the triplet loss. What is triplet loss? Triplet loss is loss function for machine learning algorithms where a reference input called anchor is compared with the matching input called positive and non-matching input called negative. The distance from anchor to the positive is minimized and distance from the anchor to the negative is maximized. An early formulation of triple loss was introduced without the idea of using the anchor for metric learning from relative comparison by Yam Skuj and T. Zongsims in 2003. What is triple loss? Look at the figure, you can see that what is triple loss. In triple loss, there is anchor. Anchor means our point. Yeah, and there is a positive and negative radical oh yeah, matching and non-matching point. In triple loss, there is anchor and negative and positive point. It is first assigned randomly. Yeah, it is first assigned randomly, and we what are trying to do in this machine learning algorithm loss is that we try to minimize the distance between anchor and positive, this green point and the anchor point. We try to minimize the distance between the anchor and positive points so that there is the matching between, to get the matching between the input and the our intended true level. And we try to maximize the distance between the anchor and the negative point. Here, blue and the red dot, we try to maximize it. When learning, we try to maximize the distance between the anchor point and negative point, and minimize the distance between the anchor point and positive point. Basically, it is the evaluation matrix. Loss function, that is how it is evaluated by using the by calculating the distance between the anchor and positive and anchor and negative point. The lesser the anchor and positive point, the greater the accuracy, greater our prediction accuracy, and we try to maximize the anchor and negative point to not get the false prediction about the level. Okay, by enforcing the order of distances, triple loss model embedded in a way that a pair of sample with the same levels are in this similar distance with the different levels. Unlike TSNE, which preserve the embedding order via probability distribution, triple loss works directly on the embedded distance. Therefore, it is common implementation. It nears the soft margin treatment with the slack variable alpha in his loss style formulation. So basically, it is used in the embedding layer itself, and it is mostly used in the learning to rank word embedding, throughput vector, and metric learning. Purpose of this triple loss is: consider the task of training the neural network to recognize the face. For example, admission of the high security zone. A classifier trained to classify the instance would have preliminarily retrained every time a new person is added to a face dataset. This can be avoided by posing the problem as a similarity learning problem instead of the classification problem. Here, the train network is trained using the constructive loss to output a distance which is small if the distance belongs to a known person and large if this image belongs to the unknown person. However, if you want the output to the closest image to given image, we want to learn a ranking, not just a similarity. Triple loss is used in this case. What is trying to say is that if you want to train the uh, classifier model, for recognizing the faces. If new person is added to the organization, we have to retrain it every time one new person face is added to the database. That face is added to the database, we have to retain it. It is computationally expensive and redundant. This can be avoided by changing the problem of the classification to the checking the similarities of the images. We in this problem we try to predict the similarity of a person face to the original face, which and so there the distance between the positive and anchor, positive and the similar faces, we ranked according to this face, and we solve the problem of every time retraining the uh, model for the new person added in the database. Loss function. The loss function of the triple loss is described by the means of Euclidean distance, that is simply a geometrical distance between the 2 point coordinate x and y. Suppose you can calculate the Euclidean distance. This is the loss function anchor point, positive and negative. We want to maximize the distance between the function of anchor point and the positive, and minimize the distance between the anchor point and the negative. And there is alpha means slack variable. Just like here, you can assume it as bias. It is given to make the model. I think A is the anchor point, B is the positive point, and N is the negative input of the class of A. And alpha is the margin between positive and negative here. F is the embedding. Simply this is the function of the which can be, it is, this can be used as the cost function, that is the sum of all the losses, which can be minimization for the post optimization problem. We got to minimize this loss function, which is calculated by this equation. Comparison. Let's comparison here. In computer vision, such as re-identification, a prevailing belief has been triple loss is inferior to the surrogate loss, typical classification loss, followed by oh, followed by metric learning strength. Recent work has shown that the model trained from the sketch as well as written model, a specific version of the triple loss, is doing into in deep metric learning outperform most of the other published method as of 2017. It has become more and more famous because it is outperforming the classification problem. Because when the new database is added to the database, it needs to be differently. We are not going to classify it, we are identifying it. Identifying and classifying are the two different things. We are seeking the similarities using the triple loss. Yeah. Additional triple loss is has been extended to simultaneously maintain the series of distance adders by optimizing the continuous relevance of the degree with the chain of the distance inequalities. This leads to the ladder loss, which has been demonstrated to performance enhancement of the visual semantic embedding learning to rank tasks. What is the learning to rank task? Learning to rank or machine learning ranking is the application of machine learning, typically supervised or semi-supervised or reinforcement learning, in the construction of ranking models for the information retrieval system. In natural processing, triple loss is one of the loss functions considered for the bird fine tuning in S-bird architecture. Like I say, it is used for the similarities. Yeah, triple loss is, what does it do? It tries to minimize the distance. It tries to minimize the distance with the positive pair, that is matching pair, and distance between, and try to increase the distance between the non-matching pair. So the closer the distance is, the more similar it is. And how are we trying to rank it based on the, we are trying to rank it based on the distance between the anchor and the positive matching pair. There are different matching pair, and we can try to calculate the closest distance is the rank first. This is similar to likely the first shortest distance is the more likely the outcome we wanted. So this is it for today. uh, I hope you like this video, and let's learn along with the real Sanjeev in machine learning. Thank you.